All right, so in terms of the genetics and the dihybrid cross here, we're going to let's talk about this. So I want you to kind of think about the F1 generation. And so with the F1 generation, this is where you have let's say you have big G, the big I, and you cross that with little g, little I. Okay, and if these two cross, then you're going to end up with big G, and big I, little I. Okay, so you're going to end up with big G. There we go. So you're going to end up with big G, big I, little I. Okay. Now in the F2 generation, if you cross this with another big G, big I, little I, then you end up with what we're talking about here. Okay, and this is that dihybrid cross. All right, so dihybrid cross. Okay. So with that, how do we come up with this Punnett square? And so big G here, big I here, big G here, little I here, little g here, big I here, little g here, little I here. Okay, and so that's going to give you the sperm options, and you do the same thing to get the egg options. Okay, and so this comes here, this goes here, this comes here, this goes here, of course, right, so forth and so on. All right, so we keep going with that. All right, so now here's the thing. So here's what I want you to know is that if you do this, then, and I don't want you to have to do this on the test because it would take way too much time, but what I do want you to know is with this, you should get and this is under normal Mendelian genetics, not incomplete dominance or penetrance or incomplete penetrance or codominance or anything like that, but you should get a 9 to 3 to 3 to 1 ratio. So a 9 to 3 to 3 to 1 ratio. Okay, and so with that, there is a 9 in 16 chance, right? So out of the 16 opportunities here, and so again, this is with one pregnancy. We're talking about two different alleles, two different characteristics, but one pregnancy here. Okay, and so two different characteristics, and looking at the probability of the outcomes with these two different characteristics. Okay, and so there is a 9 out of 16 chance that you will be dominant for one but recessive for the other. Right, and so this is Pearson's education, by the way. But if these two come here, then that's going to give you, for example, green is dominant, right? Inflated is dominant, constricted is recessive, and yellow is also recessive. Okay, and so with that, there is a 9 in 16 chance, and I'll do this in the color just to make it. There we go. And so there's a 9 in 16 chance that you'll be green and inflated, right? So green and inflated, right? And so that's nine opportunities to be green and inflated, okay? But likewise, there is a 3 out of 16 chance of being dominant for one but recessive for the other, right? And so as in being green but constricted. So there's a possibility of being green, but little I means constricted, right? So two recessive alleles for the shape, right? So here's green but constricted, green but constricted. Likewise, on the other hand, there is a 3 out of 16 chance of being dominant for shape but recessive for color, right? So dominant for shape but recessive for color. So being yellow but inflated. Here's yellow but inflated, yellow but inflated, yellow but inflated. Right, and so there are the yellow but inflated, right? But likewise, there is only right a 1 in 16 chance that you will be dominant for one, right? I mean, there's a 1 in 16 chance, that you will be recessive for both characteristics. Recessive for both characteristics, and so there's only a 1 in 16 chance of that happening, right? And so here's what we're talking about. And so what is the likelihood that you will be recessive for shape, but also recessive for color, right? And so there is a 1 in 16 chance of that happening, and that's this one right here, right? And so giving both parents are heterozygous for both characteristics, right? There's only a 1 in 16 chance of this happening, right? And so what you want to make sure that you understand is this right here, which is that you should have, under normal Mendelian genetics, you should have a 9 to 3 to 3 to 1 ratio, right? In terms of the in terms of a dihybrid cross. Okay, and so definitely know that. And so obviously, again, if you're heterozygous for both characteristics, so we're heterozygous for shape and we're heterozygous for color, right? Then mom and dad both have the dominant characteristics, but they are carriers, right, for the recessive characteristic. Okay, all right. So definitely know that. Okay, all right. So let's go back to the questions and do some questions here.